In this video, let's work on the sign test and let's understand the hypothesis here and how we go about it. So what's the idea here? Remember, we assume a non-normal distribution, so it's a non-parametric test. The reason we cannot replicate the same t-test as before is because the distribution is not normal, and remember that whenever we give a conclusion in a test, we compare it to the critical values of that distribution, and since the t-distribution has a normal distribution, then the critical values come from a normal distribution. It is not logical to compare values from a non-normal distribution with values from a normal distribution. That's why we don't do the t-test. We're performing here a binomial distribution. So what the sign test does, it takes the differences between those two groups, and in our case it's going to be before training and after training, sales before training, sales after training. We're going to take those differences, and because it's not a parametric test, literally the word parametric comes from the word parameter. Parameter in this case would be value, number. We're not interested in the actual value, in the actual number of the difference. We're interested in the sign of the difference, aka the sign test. So the sign is going to tell us whether the difference is positive, meaning that after training sales increased relative to before training sales. So let's say we have a positive difference, a negative difference, no difference, etc., etc., and so on. Now, what does this tell us? It tells us only whether we have positive or negative differences, but it doesn't tell anything about the magnitude. We're not touching the parameters, the actual value of those differences, because it's a non-parametric test. Under the null hypothesis of a sign test over here below, we're going to write, is that the proportion of positive difference is 0.5, and under the alternative is that the proportion, let's say for this case, would be greater than 0.5. How do we interpret this? What is 0.5? Well, this is a 50% proportion, meaning that we're having an even proportion of positive differences and an even proportion of 50% of negative differences. So if we have that, then that means sometimes after training sales increased, other times after training sales didn't increase, they decreased. So if that is the case, then basically there is no significant increase in sales, because sometimes it's higher, sometimes it's lower. On average, there is no difference. But if that proportion is significantly greater than 0.5, then most of the times sales increased after the training, so we would have evidence that the average sales after training are higher based on this test. Hope this makes sense. Now to compute the test, we're gonna do a binomial test over here. So we're gonna use the binomial distribution, and let's give some numbers to make it more meaningful. For the sake of the example, let's say that out of the 10 observations here, we calculated to have 7 positive differences, 2 negative differences, and 1 zero difference. So what happens in the sign test, because we're interested in differences, we're excluding the difference that does not exist. The zero difference is no difference. So we're taking out of the sample, meaning we're gonna work just with the 9 observation sample. Now what the p-value is gonna be of the binomial distribution, we're gonna calculate a probability that we're having at least 7 positive differences, given that the sample size is 9 and the proportion under the null hypothesis is 0.5. So under the null hypothesis, we expect to have a 50% proportion of positive differences, and out of this sample, what is the probability that we have 7 positive differences or more? And why do we take into account 7 positive differences or more? Because the positive differences happen more often, so it is more likely to have positive differences. Because it is more likely, what is the probability of this happening just by chance? Because if this happened by chance, then there is not enough evidence that we do have more positive differences. So it is not enough evidence that sales increased after training. Hope this makes sense. In the same analogy, with the same logic, we could give this conclusion as the probability that we're having at most, so at most 2 negative differences, given that the sample size is 9 and the proportion is 0.5. So if we have 2 negative differences, it is unlikely to have 2 negative differences, meaning what's the probability of having at most these 2 negative differences by chance? And by looking at the binomial distribution, you'll notice that the values that we're going to calculate here, which is going to be x equals to 7, 8, and 9, given that the sample size is 9, and here the values are going to be x is 1, 0, and 2. Well, those 3 pieces of probability that we're going to add are going to give the same number. This one and this one is going to give the same p-value, and that p-value is going to give us the data to give the conclusion. Let's say, for the sake of the example, that p-value is equal to 0.11. What we're saying right here is that the probability of having at least 7 positive differences between after sales and before sales is equal to 11. So the probability of this happening by chance, of having at least 7 positive differences, is 11%. That's very high. If it is higher than the significance level we allow, because we only allow a significance level of 5%. So we only allow 5% probability to have such a difference by chance, because remember, it's statistic. Chances happen, randomness happens. So if we exceed our allowance of 5%, then we do not have enough evidence that the proportion is greater than 0.5. We do not have enough evidence that sales increased significantly after the training. That's the logic of the sign test. Hope this all makes sense. In the next video, we go to the last one, which is the test on differences between proportions.